Hello, everybody. Welcome back to another session of 10 minutes of learning. Today, after we have gone through all the basics of the RLC, RC, RL, all those circuits and how they work, uh, I think it's now the time to approach the theoretical knowledge with some numerical questions. So, we'll do it in step by step. So first, in today's video, let us address this particular question. I hope all of you can read it. An AC voltage of 80 plus J60 volts. That means V is equal to 80 plus J60. For those who are a little bit confused, let me tell you, 80 is the real number, 60 is the imaginary number. J is taken as the electrical equivalent of the imaginary part. In mathematics, we take I, but since in electrical engineering I means current, so we do not take I as the complex number, the imaginary part of the complex number, we take J. So we'll continue with that. So an AC voltage of 80 plus J 60 volts is applied to a circuit and the current flowing is minus 4 plus J 10. So I is equal to minus 4 plus J 10. Find the impedance of the circuit. That means you have to find Z, power consumed, the P, and the phase angle, that is theta. These are the three things that we need to find. Now let us approach the solution one by one. So this is a rectangular form that you can see here. Both of them are in the rectangular forms. So it is better if we convert them to polar form, since we have to find out the phase angle. So it's better to convert them into the polar form. So just let me remind you the basic rule to convert rectangular form to polar form is, for the magnitude, what you need to do, you just need to do root over of 80 square plus 60 square, that is the root over of the real quantity plus real quantity square plus the imaginary quantity square. So that should come to around 100. And for the angle, it's basically tan inverse of the imaginary quantity divided by the real quantity. So 6 by 8 is basically nothing but tan inverse of 0.75, uh, which gives the angle of 36 point, I guess, just a minute, yeah, 36.9 degrees. So this is for the voltage. Magnitude and angle for the voltage is, magnitude is 100, so V can be written as 100 to 36.9 degrees. Okay, similarly we'll do the I also, and if we do the I, it will come to around, let me do the calculation first, it will come to approximately 10.77 in the magnitude scale, and the angle will come to 111.8 degrees. Okay, so from here we can calculate the Z very easily. So Z by Ohm's law, it will be V by I, and V by I means, let's go to the next slide. So V was 100 division of 36, I was 10.77, angle of 111.8 degrees if I'm not wrong. Yeah, so Z will be division of V by I, which makes it equal to 100 by 10.77 for the magnitude scale, and for the angle it will be 36.9 minus 111.8 degrees on the angle scenario. So that makes it 9.28, 9.28, the angle of minus 74.9 degrees, minus 74.9 degrees. So what does this mean? This is the, sorry, this is in ohms. So Z is equal to this. So what does this mean? Let us come to that. This means that if you convert it to, this is the polar form. If you convert it to the rectangular form, then Z will come to around, just have to simply do one thing, that is 9.28 cos of whatever the angle is there, that is minus 74.9 degrees, and then minus j sine of minus 74.9 degrees. This should come to, for the real part, this should come to 2.42, 2.42 minus j into 8.96 ohms, which means that the real component, or R, the resistive component, is this one, and since this is minus j, that means xc, or the capacitive component, is this much. Okay, so this is a very interesting solution that you have got here. From the Z, if you convert it into the rectangular domain, you have already found out, since this is minus, it will be xc. If it were plus, then it would have been xl, that means inductive reactance. So this is the value of inductance. So the first part, the impedance of the circuit, it is obtained. Now let us go to the power consumed. So power, we know, can be given by three things. For this we will consider I square R, because we know that xc will not consume any real power. The real power is consumed only by the R. So I was how much? Minus 4 plus j 10, right? Which made its magnitude to be 10.77 amperes. We will not consider the angle, because the phase angle has nothing to do with the magnitude, and we know that power is a scalar quantity. It depends only on the magnitudes of the components. So 10.77 square into the value of the resistance, that is 2.42, and that should come to around 280.703 watts. Guys, please remember to write the unit after the result, otherwise it makes no sense. So as per the problem, the power consumed has been found out, and finally we'll go for the phase angle. So phase angle theta, it can be found out in a very simple way. So it's basically nothing but the difference in the angle between V and I. So since we have already found out the polar forms of V and I, we know that V is at an angle of 36.9 degree, whereas I is at an angle of 111.8 degrees. So if you uh, subtract them, then we have already found out how much it was. It was minus 74.9. Can you see? We had already subtracted that. So minus 74.9 degrees, which means that in a coordinate system, 36.9 minus 111.8, which gives 74.9 degrees minus, that means theta is equal to 74.9 degrees leading. So we have already established that the impedance consists of XC, that means capacitive load. When it's capacitive inductance, then that we know that the current will be leading the voltage. So this is your final answer. The current will be leading the voltage by 74.9 degrees. If you have to draw a phasor diagram, it will be like this. This will be V, and if this is the perpendicular, you can imagine the final current will be somewhat, pardon my drawing please, somewhat like this. This will be the current. This angle will be 74.9 degrees in a leading capacity. Understood? This was one of the very conceptual problems that we addressed in this video. See you in the next video with another problem. Bye bye.